Hello and welcome to ThePrint. I'm Snehesh Alex Phiip. Today I, along with my video journalist Mohammad Hammad, are here in Kanpur in Uttar Pradesh. As you can see, what's written behind me is Lohia Aerospace Systems. Now you must be wondering, why am I here? Remember Operation Sindoor. During Operation Sindoor on the 8th of May and on the 9th, multiple air defense radars and air defense systems of the Pakistani military was taken out by the Indian Air Force. The Indian Air Force had used loitering munitions to take them out. Interesting is the fact that the Lohia Aerospace Systems has a role in that. The Aeros Structures, or one of the loitering munitions that was used, were manufactured here in Kanpur. They are one of the largest composite manufacturers when it comes to the aerospace sector. While they are mainly focused on exports, they are also now looking at the growing India market. What we'll do now is take you inside the Lohia Aerospace Systems to talk to Anurag Lohia, the man who runs this enterprise, to understand what the business is all about and the way ahead. Good
Hi
morning.
Snehesh. Hi, good morning. Welcome to Kanpur. Welcome to Lohia.
Thank you so much. It's a pleasure being here. I still remember I'd covered this particular facility way back in 2021 in one of my stories at ThePrint. So it's now a pleasure to actually come to this facility and speak to you.
Uh-huh. It's a pleasure now. And that time we were starting live, but now we are absolutely in the thick of things. And I'll show you what we do. I'll show you what we are. So we started live in 2019
Okay.
when I acquired my Israeli company. And then we started designing the
Which
Indian
was this Israeli company that you
called
acquired?
Light and Strong.
Light and Strong. Okay.
Yeah, it had been in existence for a while, maybe 12 years when I acquired it, and it is still the largest independent composites producing company in Israel, and they
Okay.
cater to all the customers, and I wanted the top technology, so that's why I acquired them.
So, what made you really enter the defense and aerospace sector? If, just for our viewers, you're part of the Lohia Group. What exactly is Lohia Group into?
So the Lohia Group is into several things. We manufacture machinery and equipment for woven bags. We are the largest in the world. We are also in the auto component space. We do some other stuff as well. And I wanted to do something for my country. I wanted to also expand our horizons. Defense was something that also protects us. Defense is something which is high tech. So the Honorable PM Modi ji had already established the Make in India program. Kanpur was a part of the UP Defence Corridor. So we are in the Defence Corridor. We are a Defence Corridor unit.
Okay. And how big is this facility?
So we have about 10 acres of land here.
Okay.
And this facility today is about 80,000 square feet. And we have the possibility to go up for another 350,000 square feet in the same land parcel.
But correct me if I'm wrong, you're not just functioning out of India. You actually, most of your business is focused on either defense and aerospace sector, or business is focused abroad for exports. And your factories in other places also?
Yes, the group has factories in other places. We have our first factory for Lohia Aerospace, of course, in Israel. And today our business is predominantly exports. We do work for both civil as well as for defense. Earlier, a lot of work we were doing for civil, for the 767, for the 737 conversions. But now a lot of business that we have is defense.
So when you say conversions, these are passenger aircraft being converted into freight ones, cargo ones.
Exactly.
Okay.
Passenger aircraft which have run their passenger lives,
Yeah.
but they are still good for flying another 10, 15 years. Those aircraft are purchased by converters, and then they pull out all the interiors, and then they put in new interiors. The new interiors largely consist of air ducts,
Yeah.
storage spaces, and lighting.
Okay. Viewers, this is interesting because while Boeing and Airbus are the largest passenger aircraft manufacturers and they also do cargo aircraft too, the biggest converter or the biggest player in the whole converter business is actually Israeli company, which is the IAI, which is Israeli Aerospace Industries, of which you are in partnership with for multiple of their projects, right?
Multiple projects, and we are the largest supplier for composites for their conversion programs.
Okay, there you go. So let's go inside and we'll talk further about the whole process and the business ahead.
And I'll show you the process that we have done, that we are building. Thank you.
So the journey actually starts from the quality. I thought the journey ends with quality testing.
So the journey starts from quality, because quality cannot be measured, quality has to be produced.
Okay.
And quality has to be ingrained in every single process. We manufacture thousands of parts a day. If we start measuring everything, we would never be able to produce anything, we would just be measuring things. So the quality has to be a part of the ethos. And that's why everything starts with the quality lab. And that's why this is the first room in the factory.
And what happens here? So what is being tested for quality?
The first thing that we check for quality is actually the incoming material.
Okay.
We qualify our suppliers.
Okay.
We send a team to qualify suppliers. All the documentation. Even after that, once things come here, we check sample, we check a part of every batch that comes here. So this is an interesting machine. It's called a universal testing machine. This measures the tensile strength this can measure the tensile strength of hard materials, soft materials, fabric, and even manufactured composites.
Okay. Yeah. So this is where the raw materials are tested.
Yeah.
So every single raw material is tested here for quality, batch-wise, or how is it done?
It's done batch-wise. Every single testing would take too long a time. We qualify our suppliers for that. Okay. Even then, we test a part of every single batch, and we keep records of all those test reports, and also a cut sample of every batch. So that
cut sample of every batch.
Every batch. Maybe 10 years later, you tell me, okay, this part was produced bad by you. I said, no, I can prove it to you because I have a sample from the part that I produced in, let's say, 2025.
Interesting. So I'll ask you a very, a dumb question. We talk about composites, right? You are the biggest supplier, as you mentioned, for the IAI when it comes to the whole the conversion business of it, programs of it. But even the aero structures that you build for multiple drones and loitering munitions are also made of composites.
Exactly.
So what exactly is a composite?
Very interesting question, Snehesh. A composite, at its basic level, means a mixture of two materials.
Yeah.
So in our specific particular case, a composite means a mixture of a fabric, which could be carbon, which could be glass, which could be aramid, and it is mixed with either a phenolic or an epoxy resin. To give it carbon, as you know, has a much higher tensile strength than even iron, and it is 7 times lighter than iron. And mixed with resin, it can give you a product which is, let's say, between 5 and 7 times lighter than iron with a higher tensile strength. And that is a composite. And in our case, the composite uses things much more than just carbon and epoxy. We also use sandwich structures, we use honeycombs, we use fillers. That depends on the customer specifications.
So, for example, a lot of cars, come with parts which are made of composites. Now, for example, even when it comes to fighters, also a lot of composites is used. Yeah. Even for civil airlines, also, composite is used. Yeah. So, if why don't you show us what exactly is a composite and how is the process really? The beginning of the process and the end of it.
So this is one of the ways that manufacturing starts. This is something which is called a honeycomb.
Okay.
This is used as a sandwich structure. When you sandwich it between glass or carbon or aramid, this particular baby is also made of aramid.
Okay.
Yeah, and this particular.
What is the material that you used?
Carbon, glass, and aramid.
Actually, aramid.
Yeah.
Okay.
Aramid is actually stronger than carbon. It has a higher tensile strength than carbon. And when you want to use it as a barrier, then people use aramid. It's much more expensive than carbon.
It's much more expensive than carbon.
Yes.
And this is brown in color, and this is.
Oh, this is metal. This is aluminum. This is an aluminum honeycomb.
This is an aluminum honeycomb, and this also comes under the whole composite.
Exactly. Exactly. Okay. It will come under the broad heading of composite because you will have glass and carbon sandwich over. This per se will not be composite.
Okay.
But once you sandwich it between glass and carbon and epoxy, this becomes a composite.
Acha. Okay. And you were telling me that this also has to be stored in special
This
conditions.
has
You're
to be
talking
stored
about a
in
freezer
yeah.
that you were talking
Oh,
about.
yeah. So this has to be kept covered because it oxidizes. So I opened it to show it to you. And since it is open for a few minutes, somebody will record it that it was open from, let's say, 10 o'clock to 10:15, and the overall life of this material will be reduced by those 10 minutes for usability.
For 10 minutes of
Or
those
whatever,
usability.
whatever.
Okay,
Yeah.
understood.
Somebody recording it.
Okay.
Yeah.
So we'll now walk to the freezer. If you
Yeah.
could.
Yeah. I'll show you the freezer.
So what is this freezer all about? Cold storage conditions, temperature minus 18 degrees Celsius or below.
Yes. So this is an interesting material called a carbon prepreg,
Okay.
which means that it starts life as a carbon filament. It is woven into sheets, and then people like Torre or Hexcel, they will manufacture it. They will apply resin to it inside their factories.
Okay.
Once the resin is applied to it, from then on till the time it is used to manufacture products for us, it has to have a maximum temperature of minus 18.
Oh, that's a maximum.
Exactly. Through
Not
the
the
whole.
minimum.
No, that's the maximum temperature. It has to be below minus 18. So at the this freezer is now at minus 22.
Okay. Oh, wow.
Yeah.
Okay.
And it has to maintain
Can we
this.
go inside the freezer?
Well, if you want to,
Uh-huh.
you can't
No,
stay
just
too
for
long
the viewers,
inside.
because
Of
the
course.
viewers want to see.
Of course.
I have seen it already,
Yeah.
but for the viewers, so viewers, as you can see, there's already ice on these plastic curtains that are there, and it's really cold. Trust me, it's very cold. We are right now in minus 22 degrees Celsius. And what is this that you?
This is the carbon prepreg that I was telling you about. This one is manufactured in Italy, and when it left the factory, it left in an air-conditioned container. It came on a ship in an air-conditioned container. We downloaded it, put it here, and since then it's been inside. There is a data logger here,
Yeah.
which records the full temperature from the time it left the factory till the time it is used.
So this has to be minimum maximum
Maximum
minus
minus
18
18.
degrees Celsius.
And that data logger records the temperature it has been throughout, including the time that it has been outside of a freezer.
Okay. Viewers, I would have loved to be in here, show you more, but it's really cold and we are already freezing.
Yeah.
So let's step out.
Yeah. So this, you asked me how it started. So I showed you the honeycomb. Now this is carbon fabric.
Okay.
This is the carbon fabric. Now this is used as a cover for the honeycomb. The honeycomb is to increase the thickness.
The density of
The
it.
density, increase
thickness,
the
okay.
thickness,
Yeah.
thickness, because it becomes stiffer. This lends the tensile strength, that lends the stiffness.
Oh, okay. And is this treated with something?
Yes, so it either comes treated like when I told you a prepreg, which is stored in the freezers.
Yeah.
This is dry fabric, in which we use resins ourselves manually. All the resin is stored here. Here also, this is also temperature controlled.
Okay.
And we buy resin separately and the fabric separately. And our technicians here, they infuse this with the very high quality resin. A lot of it made by 3M, a lot of it made by Torre.
Okay.
Yeah.
And these resins are manufactured in India or are they imported?
There are some manufactured in India, but we largely import them.
We largely imported. Okay. So as I keep saying this, while India is focusing big on defense manufacturing, a key element of the defense manufacturing is the supply chain and the need to have more companies in the supply chain business. Like for example, a simple thing like the resins that he's talking about, as he said, while some are manufactured in India, a lot is imported from abroad. And that's where the focus should be.
So I'll now take you to the actual manufacturing,
Okay.
where we use the prepregs and the dry fabric and assemble them in tools. So this is actually where manufacturing really starts.
Okay.
For every single composite manufacturing process, you need a tool, a layup tool. And for example, a bird which has a 4-meter fuselage and a 6-meter wingspan will require something like 200 tools.
Okay.
Yeah.
And so these tools are manufactured by?
We take the full responsibility for the tools. We
Okay.
design the tools, we either manufacture it ourselves or we get it manufactured outside, and we take the responsibility for the manufacture and the quality.
Okay. So, so when you say that you manufacture aero structures for various kinds of drones, loitering munitions basically, what is that those aerostructures all about? You know, is it just the fuselage or is the wings that you're currently showcasing?
So an aero, if you see a loitering munition fly,
Yeah.
everything that you see is a part of the aerostructure.
Okay.
Everything that you cannot see inside are the electronics, the avionics, the first person view cameras, the software, harnesses, they are all inside. But everything that you see is a part of the aerostructure and all manufactured by us.
All manufactured by you for the Israeli company?
For several companies, including some Israeli companies, of course.
Okay,
Yeah.
okay. So some of these products, you know, as I was mentioning, have been used in multiple, for example, you know, whoever that you supply to, they are selling these products in multiple places. So some of these products have been used in conflicts and also including in Op Sindoor that I'm aware of.
Yes, I haven't told you, but they are used.
Okay,
Yeah.
there you go.
Yeah.
So these structures are made here in India.
Yes.
And then they are exported to whoever the customer is.
So they are made in India and they are exported to whosoever the customer is. We do it in two stages, wherein we simply make the aerostructures, we sell it abroad, and then the my customer would put in all the electronics and the avionics that I
Yeah.
told you about, and then send it to their customers. However, for certain customers, we also make the birds in a fly-away condition, which means that we buy or our customer supplies us the electronics and the cameras, we assemble them here and then we sell them in a fly-away condition, which means that our customer simply removes the shipper name from us to them and then sends it ahead to their customers.
Sends it out to the customers. You know, this is something that I wanted to see and make you see, but unfortunately, due to security reasons, we will not be able to showcase
The assembly areas.
the assembly areas. But we will now take you to the manufacturing, to more manufacturing process to understand, you know, how does the final product really shape up? What is this that I see on the wall?
Oh, this is very interesting. I'm glad you noticed it yourself.
Ah.
So this is a bird manufactured by an Israeli company, which actually has an endurance of several months. It has solar batteries, and this has a camera on the bottom,
Okay.
which gets the Google Street View kind of data, and it sells it to companies like Google Earth. They sell it to companies like Map My India.
Yeah.
So the data is actually collected by third parties. Google themselves don't collect data. Map My Earth doesn't collect that data. That data is collected by birds like these, and we manufactured them.
You manufacture them?
Yes.
Your company in Israel
My company
manufactures?
in Israel manufactured them.
And this has an endurance of 3 months, you say?
Yeah, between 3 and 6 months, depending on the model. This, I'm not sure. This looks a little smaller,
Oh,
so this
okay.
perhaps would be about 3 months. So this is a very interesting bird. It's a small bird with an endurance of about 1.5 hours, and the advantage of this bird is that it is simultaneously a loitering munition and a surveillance.
The reconnaissance
UAV,
one.
reconnaissance and surveillance. So
Oh, okay.
yeah, so if it does not expend itself, it can land with a parachute, and it can, like a boomerang, it will come back to the place where it is launched. You can stop, collect the parachute, stuff it back, and the data is already there with the operator by the time it lands.
By the time it lands.
Yeah.
We are not talking, we are not taking names here, not mentioning companies, but as I said earlier also, and he said, they are supplying to multiple companies. So this is one of the, this is the wing of one of those loitering munitions come reconnaissance one, which I'm sure the Indian military also uses besides other countries as well. So, and what is, I can see there's a difference between these two.
Yeah, so this we do the full assembly process.
Okay.
The electronics is inside,
Okay.
and this is poking out, so which can get connected when you assemble the bird.
Okay, okay.
Yeah, and as you rightly noticed, there's a difference between this and this.
Yeah.
This is something which is called an aileron.
Okay.
This is controlled by a motor which is behind this.
Okay.
We buy the motor, we assemble it here, and this is controlled by software mid-flight to change the altitude and the direction.
And the direction. So when you say the motor that you buy, where is this motor procured from?
I can tell you, but I'll have to kill you.
I hope it's not Chinese. That's all I'm saying.
No, there is, so I don't know if I can say this, I can say
Yeah.
this. For one of my customers, a very, very, very large American contractor, I had to give a declaration that in the room that I produce parts for them, even the chairs will not be imported from China.
Oh, wow. Okay.
And I had to give a personal declaration as the CEO.
And that even the chairs would not be.
Even the chairs will not be
this is completely in contrast to some of the government facilities that you would have seen on social media, several posts where the CCTV cameras were actually Chinese.
So ये मैं आपको दिखा देता हूँ. This is just to show you the different layers of carbon.
Okay.
So for example, this is about 25 millimeters, but this would have something like 300 layers of carbon inside.
300 layers of carbon inside. I'll ask my video journalist to actually focus on this. This particular, sample is made, as he rightly mentioned, is made with 300 layers of carbon. Absolutely light. So what are the other structures? These are not, doesn't look like aerospace structures.
No, you're sharp. They're not. So this is the exhaust system for a Lamborghini.
Oh, okay.
Yeah.
Okay.
This is made for an Austrian company.
Okay.
This is again the exhaust for a motorbike. I don't recall it, the model of the motorbike. I think it's Triumph, but don't hold me to it. But I think it's Triumph.
But it's always nice when you're manufacturing a lot of things for multiple companies that you actually forget as the CEO or as the owner, you forget which part is for whom. But there's a process in place. Okay.
This is the cover for an air conditioning duct for a cargo plane.
Okay. This is the converted one that you're talking about.
The conversion, as you can see, it's so light.
Oh, this is absolutely light.
Yeah.
Okay.
And you can't even bend it a millimeter.
That's how tough the carbon is. I never thought till a few years back that carbon could be so tough. Now,
This is the rear spoiler for a BMW 3 Series sport vehicle.
Okay, okay. So all those who have a BMW, well, this is where it is manufactured here in Kanpur. Now, what are these?
So this is the rudder. Again, this is the Aeron, like I told you.
Yeah.
Here the motor will come and it will control the rudder. So it's a big, it will be mounted like this, and this will control the lateral movement.
I know.
This is the boom of a surveillance VTOL.
Okay.
So here is where the propellers will be mounted.
And this is the, oh wow, this is like absolutely light.
Yeah.
How much would this weigh?
This would be something in the range of 850 grams something.
850 grams?
Yeah,
So
and we control it. This is composite, and we control it within plus minus 30 grams.
With plus minus 30 grams.
Yeah.
So if the same thing had to be made with, let's say, titanium, how much would this have weighed?
This would be at least 5 kilos.
5 kilos. And if the same thing was made with, let's say, steel?
I don't know, 8 kilos for sure. 8 kilos for sure.
So that's how. But the strength remains the same, or is there a change in?
Look, one is the strength to weight ratio of steel to composite depends on a lot of factors, including the resin, the thickness, the curing time, etc., etc. On a order of magnitude thumb rule, you can take it as 1:10.
1:10.
Yeah.
And now you have more the wings and all of multiple
These are
other birds.
yeah. This is just 1/2 of the wing, and you can see it by
The size.
by the size,
The
by the
length of
reference.
it,
Yeah.
yeah.
This is just 1/2 of the
Just
wing.
1/2 of it.
Yeah.
That's how
Yeah.
huge
Yeah.
these drones are.
And this goes here.
So this goes there.
Yeah.
Okay. Okay. And this is what is this?
This is also a loitering munition.
Okay. This is also a loitering munition. So
Yeah.
this is the one that the main fuselage which actually flies.
This is the main fuselage. This is the wing.
Okay.
And then we also build the landing gear, which is this cannot land by parachute. This has to have a small landing gear.
Okay.
Yeah.
Well, from the look of it, this is a smaller loitering munitions. I guess this is also a loitering munition.
This also is a loitering munition.
But it's
Please
much
don't
larger
ask
in-
me. Yeah. I showed you the member, the stiffening member, right, of
Yeah.
composite.
Yeah.
Look, that's right here.
Okay.
Yeah. And this is so that it does not collapse on itself.
Ah, okay. So these are, so this is part of a loitering munition which is also manufactured here.
Exactly.
This entire
This entire
fuselage
thing.
is manufactured
and
here.
what you see here, this already has about 72 parts inside, not counting the composites.
Oh, wow. Okay. And it's absolutely light. Can I
Yeah, yeah.
Can I try and pick it up?
Yeah.
Oh, wow. This is This is not heavy.
Oh, this is
Good.
not heavy.
Huh?
This is not heavy.
Okay.
And if you see, the section is so thin, but you can't bend it.
So it's interesting. Why would an Israeli company or let's say an American company manufacture here in India? I'm sure usually it's the offset clause, but there are no offset clause here. So what really makes it special? What makes you special?
What makes the process special is because it's very high skill. It is a high tech product. A whole lot of people in the West, the US, Germany, Israel, they don't want to work in factories. They want to sit in air conditioned offices and do coding. So, A, B is that as a thumb rule, the labor content on a composite part is 10 times that of a CNC machine part.
Okay.
And if you can make CNC machine parts in India and export them, you can for sure make composites and export them, because the labor content is far higher, and the delta of the labor cost,
Yeah.
the labor cost differences.
So, but I was walking through your factory. We'll visit some more places. There are a lot of people working here at these factories. Now, you mentioned that they undergo several kinds of training. So, who are these people? Where do you hire them from, or what is the educational requirement that is there? And do you get to do you see the quality of people who are coming in, or do you see there's an issue of quality and there's also issue of numbers? Are you getting enough people?
So I believe very strongly that talent is overrated. I believe very strongly in skilling. We have a very large training institute owned by us, very close to our factory. However, for composites, we sent our people to Israel, to our factory for training.
Okay.
And we also partnered with an American company based in Florida.
Okay.
And we sent our people there as well for training. That was in the initial years of the company. Israel, we still send our people for training, and they undergo a very rigorous program of anywhere between 6 months to a year before they are allowed to touch a customer part meant for a customer.
So the from the educational background, who are these? They come from what? They are diploma holders. What are they?
So for the top tier people, we hire diploma holders, and for layup technicians, we hire diploma holders and ITIs. But we have a very comprehensive entrance test for people who want to work for us. Just because they are a diploma or an ITI doesn't mean that we'll hire them. We have our own internal screening test before we hire them. This is the next step in the manufacturing process. This is something which is called a clean room.
Okay.
Yeah, so we maintain 8,000 ppm, means we have just 8,000 particulate matter of 0.25 microns
Okay.
per cubic inch of air. Here.
So this is like the cleanest room.
Yes. Here we can make space pots.
Okay.
Yeah.
Okay. Which means that this is much cleaner than what you would see in Delhi. In terms of pollution.
Yes, you can say that
Huh?
if you want.
Good. I am from Delhi. I think I should take as much clean air as possible while I'm here. So this is the reason why we dress like this. We have
Yes,
to cover our
because
hair.
you could have dust on your clothes,
Okay.
which could then come and get introduced into the air here.
Into the area. And even though we are wearing shoes, we have to walk through a glue carpet which would suck in all the dust that is there, right? So what is really happening here now?
So here, the layup process is happening.
Okay.
Here we have cut pieces of fabric that I
Okay.
showed you here, which is called a pre-preg.
Okay.
And it is being assembled into this tool. You can see
Okay.
the carbon layers like this.
Yeah.
Right now it is flexible,
Yeah.
but after curing, it will be harder than steel.
Okay. So for example, this is the carbon. This is something else which is there.
This is the filler material,
Okay.
because you have to compress it. You have to suck in the air out of it through these pipes.
Okay.
So this is through which the air is sucked.
Okay.
So you saw, I told you, there were 300 layers in that
Yeah.
single piece. So here you can see, एक मिनट रुक जाना बेटा. One layer has been laid. अब आप कर दो, अब आ जाओ.
अब कर दो.
हाँ. So layer number 1, layer number 2, layer number 3 is being laid up. So when we go to 300 layers, then you will get a piece 1 inch thick.
Interesting is the fact that while I'm here, one thing that I notice is in terms of the profile here, I see a lot of women working here.
So we are very proud to say that we have one of the highest ratio of females to men. That was initially that was by choice, and then it continued because they were good workers. We are very proud of that.
Okay. So in terms of if you look at numbers or in percentage, how
40%.
much? 40% is women.
Yeah, in the shop floor.
Yeah, on the shop floor, 40% women, which is clearly visible. And that's something that one of the first things that I did notice when I walked into this factory is a number of women. You know, I'm also proud to say of the fact that back at the print, the majority and much more than 40% is actually that of women.
And because of my daughter, I can say that we have a reverse glass ceiling here.
There you go.
This is something which is called a production freezer.
Okay.
So because I told you that every minute that the material stays outside above -18, the life is cut out of that.
Okay.
So the moment they finish their work, they will put even the scraps inside. And when
Okay.
they start work, they will pull it out again.
So right now it says I can read minus 22 degrees Celsius. Well, I'm not asking you to take me inside. I think we'd had enough for the day.
Yeah.
Okay. I can smell paint here.
Because it is a paint shop.
Okay.
So interestingly, this is one of the very, very few paint shops in the country which are temperature, humidity and particle controlled.
Okay.
This is the air conditioning system.
The unit there. Okay.
Yeah, and it does not recirculate air.
Okay.
We cool the air, we dehumidify the air, we departicle the air, and we then throw it into the paint shop, and then there is no recirculation. It is taken out, filtered, and then sent to the environment.
Okay. So anything that composite part that you make undergoes the painting here.
Yes.
So this is the same fuselages for the loitering munitions,
The fuselages, the wings,
wings and the other
etc.,
parts.
yeah.
Okay. Okay. This is where it goes.
This is where it goes.
Okay.
The paint shop process also very, very rigorous. Also because in a car, for example, you do a paint and then there is a blotch. You can simply just paint it over. Here you cannot paint it over.
Okay.
You have to take out, if there is a 1 square inch of bad paint, you have to scratch out the paint all over the bird, and then you have to paint it again because there are very tight weight restrictions.
So even in terms of paint, are any regular paint used or is there any specialized paint?
There are special mill grade paints.
Okay.
Yeah, mill grade paints. There are 2 or 3 manufacturers in India, including PPG, where we buy from.
Okay.
And a lot of people, for a lot of paint, we import it as well.
Okay. We are now in what is known as the assembly point for individual parts, right?
Exactly,
So what exactly happens here now?
So here we assemble the wire harnesses, the motors,
The ones that we saw earlier.
exactly. So here the motor is mounted. You
Yeah.
put a cover on it, but it's there just so that you can see. So this is for controlling the bird mid-flight, and the motor, the harnesses. This is for the signaling. This is for the controlling.
Okay. Okay.
We do all the assemblies.
And then all these, you mentioned the fact that you also do the final assembly where you put all these electronics together and
Yes.
it's in a flyby
In a flyaway condition.
flyaway condition.
Yes.
That happens in a different
That
section.
happens in a different section, which is unfortunately not open to public or for viewing.
Okay, okay. So in terms of expansion, so now defense, you've entered the sector in 2019, right?
Yeah.
In terms of expansion, how much is defense part of the overall revenue as far as the group is concerned?
Yeah. So if you allow me, I'll introduce my daughter Anvi. She handles international sales and marketing for us, and she's also leading our foray by taking part in the Paris Air Show.
Oh, wow.
So here she is, and she'll explain our.
Hi, Anvi.
international foray.
Hi, welcome to the print. If you could, I was just asking your father, in terms of expansion, what is it that you're looking for, And you're taking part in the Paris Air Show. Correct me if I'm wrong. Yours is the first, only true Indian composite company which is going to be there.
Absolutely, that's correct. The Paris Air Show serves as a focal point for our international expansion plans. We want to expand more both in the civil as well as the defense sectors. While we already have a lot of customers across the world, we want to expand even more. The composites market globally is quite fragmented. We want to make an India first company. Our motto is make in India but for the world. We want to indigenize composites manufacturing. A lot of foreign companies don't yet turn to India for composites manufacturing, but we want to show that Indian quality can be so superior that the world can source from here.
You correct me if I'm wrong. You're already empaneled by the Airbus and Boeing. It happened recently.
That's correct. I can say we've had visits from Boeing and Airbus both. The Airbus India head of procurement, Mr. Thierry, visited our factory, and we'll be meeting with them in Paris as well. So we really hope to work with the world's leading OEMs. We recently renewed our NADCAP certification, which is one of the world's most complex aerospace grade certifications, and that will really help us enable with the world's top OEMs and make Lohia Aerospace a global composite center.
Now, I was talking to your daughter about the future expansion plans, you know.
Yeah.
So, and I come back to the earlier question. Now, you're a big group, right? And if I'm not mistaken, this is about a $400 million group.
More or less.
More or less. So, how much is defense or this aerospace unit part of? How much does it in terms of revenue?
Yeah, today it's not a very, very large part, maybe between 10 and 15%.
Okay.
But this is the fastest growing part of the group.
Okay.
And I would suppose that in some time this would we are looking at at least a 50% growth over the next 3 to 4 years each.
At a 50% growth over the next 3 to 4 years each.
Each year.
Each year, that's what. Yeah, each year. So, and where would this growth come from? You know, what are the sectors that you're looking at? Is it just the composites? Is it just with the Israeli companies, or you are expanding now into other areas also?
So no, Israel is just one country where we ship our products to. Of course, it started with Israel because of our presence in Israel even before we started the Indian company. But most of the new businesses that we are discussing about are outside of Israel, most of it. And that is why I want to focus on, because I don't want to be tied down with a single geography. UAVs, which over the last couple of years have played out, they are the fastest growing single element in the whole defense ecosystem.
Yeah.
And we are very happy and proud to be a part of that ecosystem. We are also probably the largest composite aerostructures manufacturer in the country. Like my daughter told you, we are also the only composite aerostructure company displaying in Paris today.
Yeah.
Going by the number of inquiries we are having, going by the number of regions that we are having, the future is exciting and the future is all over the world.
So even when your expansion plans you've already catered for in terms of the land that is there here at this Kanpur facility itself, right?
Yeah.
Okay. So, you know, while you're talking about expansion, and this is supposed to be an year of reforms, as far as the defense ministry is concerned. And why I'm saying is that it's a year of reforms is because this is where the new defense acquisition procedures is supposed to come out later this year, right? There have been a whole lot of talk on the decision-making process in the defense sector itself. Now, as a defense company, what is the message that you like to send out to, let's say, people in the government who are watching this and who are right now in the process of simplifying the processes, which makes it easier for companies like you to run their businesses? Are you facing any challenge at this moment?
Look, every business environment is a challenge. Even though we are a part of we are still a startup, and as a startup, it has challenges. It has people challenges. It has training challenges. It has regulatory, statutory challenges. The government is very strongly pushing the defense export agenda.
Yeah.
One challenge that we face is getting export approvals.
Okay.
There is an export approval regime in place because of the Wassenaar agreement, which translates into the SCOMET approval process in India. The process of asking for a SCOMET approval starts after you get the purchase order from a company, which means that after having spent years in quoting a customer, after proving to them that you are worthy of being a supplier to the likes of Boeing and Airbus and Embraer and Dassault. After that, and once we are given a purchase order in competition with countries all over the world, as you can imagine, then we have to start the process of an approval, which usually the government is very friendly. They are being tasked with giving approvals, but a bureaucratic process is a bureaucratic process. It takes its own time, and we are looking for a simplification of the process. There are products which are very, very high technology. There are products which are of proprietary technology. So we are a high technology product, but the process is not proprietary. The process is owned by the customers. We are a build to print company, and there are several companies around the world who can manufacture products like ours. So to ease the competition, we need an ease in the approval process for exports.
So what you're essentially saying is that first you'll have to quote a foreign company, let's say an OEM, right? You'll have to show them your processes. They'll have to come, they'll have to visit, they'll have to certify you. And then when they place an order is when you have to go to the Defense Ministry.
Exactly.
Needing the SCOMET approval.
Exactly.
Okay.
Exactly. We cannot go in advance. We cannot take the process in
but
advance.
Wouldn't it make sense, like for example, let's say if you're dealing with a reputed company like Boeing, Airbus, Dassault, Embraer, or any other recognized company, or if you're dealing with countries like the US or Canada or let's say France, the approval should be given automatically?
That's what our wish list is. That's what our requirement is.
Okay.
And so there are three distinct elements here, Snehesh. One is who the customer is. Second, what the geography is.
Okay.
And third, who the supplier is. So if the supplier, you can have a supplier which is pre-qualified. You can have reputed suppliers who are pre-qualified, so that they can give information to the MOD or whosoever it may, that we are sending goods to so-and-so countries, so-and-so companies. Then if the goods are going to reputed companies, then they should come under automatic approval. If they are going to countries like Israel or Germany or France or the US, which are, let's say, friendly countries who in turn provide us equipment, for them it should be the automatic route.
Okay.
And also especially for processes which are not proprietary to a company.
Okay. Yeah, that would make sense. I hope people in the Defense Ministry or in the government who would probably be watching this show, this is something that can be easily be taken up, because I know for the fact that the Defense Ministry and the Modi government here is pushing big as far as the defense manufacturing is concerned, and not just for the Indian Armed Forces and not just for India consumption, but also to make it for the world, right?
That I can see from everywhere. My people in the MOD try to help us. They try to solve things out, but a process is a process.
A process is a process. So what would be a bureaucratic process time and what would be your production process time? For example, let's say if you have to manufacture a fuselage, or let's say a wing, what is the process, let's say for 1,000 fuselages order come, and how much time would it take for you to manufacture them, and how much time would it take for you to, let's say, get the approvals in?
I'm not sure if I can answer that question correctly. Maybe I don't have the data correctly in my head. However, all I can say here is that there is always an element of not surprise, but let's say something not under our control. We can go out and quote a customer. We can go out and woo a customer. We can get a purchase order. We can get when we are importing material under an advance authorization scheme, we cannot even apply for the advance authorization license till the time we have the SCOMET approval.
Okay.
So we get the purchase order and we have everything ready, but to import the material, we need an advance authorization. To get an advance authorization, we have to make the advance authorization application. And to make an advance authorization application, we need the SCOMET license. Having said that, I would like to say that the Ministry of Defense has always helped us. There's been a helpline. They've always been there to help us. They've always been there to help us, but they're helpless as far as the procedural is concerned.
And I hope, as I said, the entire processes and procedures are currently undergoing a review, which has been led by, of course, Defence Minister Rajnath Singh, and also by the Defence Secretary. He's been made in charge of it. And there's a new procurement policy that is supposed to come out later this year. And one of the big concerns, and that is a concern that has been expressed also by the Air Force Chief, Air Chief Marshal A.P. Singh, is the fact that the processes are just too long, right? And there's a need to cut down on the procurement timeline as far as the Government of India is concerned. But thank you so much for having us here, for taking us through your facilities and helping our viewers really understand what a composite is and how India is playing such a critical role in the global drone warfare ecosystem.
Thank you for coming over. Thank you for giving us the opportunity to enlighten our viewers and reach out to people. There are a couple of things that I wanted to mention.
Go ahead.
We are a part of the defense corridor of the UP, of the defense corridor of UP, and that gives us a big visibility as far as customers are concerned, and as far as even government procurement is concerned. One more element that I would like let's say the government to know is the inverted GST structure.
What's an inverted GST structure?
So all our inputs face a GST of 18%. That includes raw materials, that includes capital goods, and that includes services. And the GST on finished goods, which is in our case aerospace, is 5%. So while direct raw material inputs, we get a reversal of GST, but everything else that goes into it, services, consumables, tools, capital goods, all of them we lose the GST. And that puts us at a very serious disadvantage as far as competition from outside of India countries are concerned.
Okay.
Countries like Malaysia, countries like Vietnam, countries like Thailand, which are very strong manufacturing countries, which have a long heritage of manufacturing excellence and comparable to India in labor cost. There we lose out in multiple percentages as far as costs are concerned.
Well, that is something, I'm so happy that you've raised this point, because that is also something that India will have to ponder on, because I was not aware of these challenges. I'm aware of regulatory licensing issues because I keep speaking to other industry players also, but this is something that's the first time somebody has raised this issue, and rightly so. But thank you so much once again for being here, speaking to the print, and really speaking your mind out, because while you truly believe in the India ecosystem, you truly believe in India's growth potential as far as defense is concerned, despite the fact that you have companies, your manufacturing facilities abroad. But thank you once again.
My pleasure, and thank you for giving us this opportunity.
Thank
It's
you.
a pleasure having you.